To make a few more points about the urgency of seeking these ocean solutions that benefit humanity, nature, as well as economy, as I said in the last podcast, we can pay a little attention to how much greenhouse gas uptake can happen in the ocean. So we always start with these kind of figures, which is looking at historical emission trajectories that we are on, but the trajectories that we should be on to hit some of the global warming targets. So here are various lines. The 2005 policies would take us in this direction. The current policies have reduced it a little bit under the Paris commitment period of 2025 to 2030. And then current policies and the nationally determined contributions that countries voluntarily committed to get the world about halfway through the basic baseline to the 2 degree C trajectory. But a gap of 12 to 15 gigaton CO2 equivalent remains under various scenarios here for 2C, for 1.8 degrees centigrade and 1.5 degrees centigrade. So these are the various gaps that we have to pay attention to, which means that the even the commitments under Paris Agreement are way off in terms of hitting these global warming targets with a reasonable probability of something like 66%. Here, conditional and unconditional NDCs are essentially referring to what the countries would do anyways unconditionally for their own benefits or by their own voluntary motivation and so on. Conditional NDCs depend on receiving help monetarily and other technology transfers and so on, which obviously brings it down further, but obviously still not enough at all. Here, CO2 equivalent, I hope most people know what that is. Basically, we are converting methane, nitrous oxide, HFCs, and other greenhouse gases to a CO2 kind of warming potential. It takes some calculations. There is a term called global warming potential, which is essentially looking at how the other greenhouse gases compare to CO2 over a certain period, like a century, in terms of warming. It can be done by weight, by molecule, and so on. But without going into those kinds of details, just think of it as the total amount of human impact on radiative balances that we need to take care of. And obviously, currently we are way off. So the idea here is to look at potential ocean contributions to this idea. So current policy baseline is here. Pathway to limit warming to 2C is down here. Pathway to limit to warming to 1.5 C is down here. Basically, we obviously have to reduce much more greenhouse gases by 2050 for a lower target. And we are already behind, so we are already in 2021 and we should have started drawing down already, but we are essentially on this trajectory here. Nonetheless, if you look at for 2 degrees C, ocean can, in terms of proportion of emissions gap that could be closed by ocean mitigation is 25%, and remaining gap to stay within 2 degrees C is here, so that's 75%, and you can translate that to gigaton CO2 equivalent. And for 1.5 C, ocean mitigation contributes 21%, basically because the number is larger and the ocean contribution happens to be smaller. Remaining gap to stay within 1.5 C is much larger as well. But the main point is that ocean has a role to play in meeting our global warming targets. In the meantime, if we look at certain case studies about how compounding stressors are leading to the decline of Caribbean reefs, there are many such examples. This is just one of them. So there is the location. So individual sensors of human impacts include overfishing, sediment from deforestation on land. So with warming, if extreme rainfall events are increasing, urbanization is happening, deforestation is happening, and so on, the runoff is faster and erosion is higher and sediment loads are increased, which obviously is bad for the reefs in terms of light levels, pollution, and just covering the reefs and killing symbiotic algae and so on. Warmer water from climate change. Some reefs are responding well, some are not, so that has to be understood as well. Habitat destruction, always a big thing. Pollution, nutrient pollution, for example, and other touristic pollution. Even skin cream, the sunscreen is a big pollution, for example, for heavy touristic sites like the Great Barrier Reef and the beaches which are popular here. And introduction of a pathogen. Okay, so the compounding effect is that there is a decline on average of hard coral cover on the Caribbean reefs from 50% in the 1970s to 10% by early 2000s. So the decline on average hard coral cover has gone from 50% now. The coral cover is now down to 10%, which is really bad news. Examples of indirect consequences other than direct fishing and so on also include compounding pressures on the ocean. For example, in 1950, ocean dead zones where the oxygen level is below about, let's say, 5 milliliters per liter, it becomes hypoxic when you get anoxic when you get below 2 milliliters per liter. But nonetheless, ocean dead zones have expanded by an area about the size of the European Union over the past 50 years. So in 1950 there was less than 50. Now by 2018 the number of sites reporting hypoxia or dead zones is more than 500. And global predatory biomass, in 1920 this was the quantity. It has dropped today by 1/3. Today it's about 1/3 of the 1920 levels. Okay, so we have destroyed about 66% of the global predatory fish biomass. The cost of inaction is estimated here on the global economy. Yearly cost of the global economy, if human impacts on the ocean continues unabated, in billions of US dollars per year. 2050 it'll be 428. If we still don't manage to get our act together, by 2100 it's going to be 5 times larger, to almost $2,000 billion. Okay, since this report focuses on ocean solutions that also benefit the economy, there are of course economic calculations presented in terms of the cost and benefit of investing in action and the returns. So we will look at some of those numbers. But before that, impacts of compounding effects of climate change. Here another example. A 1 meter rise in relative sea level increases the frequency of current 100-year flood events, so return period of 100 years. It will increase by 40 times in Shanghai, 200 times in New York City, which is at sea level, and 1,000 times in Kolkata in India, which is also at sea level. And Bangladesh is of course just as bad or worse. And you can see here saltwater intrusion in Bangladesh through floods and storm surges. Annual median projected change in soil salinity is plus 39% by 2050. With limited land, salinization of soil is a disaster for food production. And of course food security, which becomes clearly national security in this geopolitically sensitive region. So all those things have to be worried about. This is an example of a live interactive digital dashboard for ocean accounting that Norway is using. Essentially it's a high-level panel for sustainable ocean economy, defines the ocean economy and tracks many things. So fisheries value, mining, oil and gas, transportation, tourism, income change, percentage relative to 2016, income and other market services, non-market services, define the reference year 1978 to 2016, and so on, and looking at partial balance sheet for fishery stock and pollutants and so on. Obviously, I'm not going into details, but the idea is that these small rich countries are progressive in climate action, and countries like Norway depend heavily for their offshore oil production as well as fisheries and other marine services. How is the ocean account different? The box that I took from a future third chapter, is talks about key triggers to develop and mainstream ocean accounts. Create national ocean accounts covering product, income, balance sheets, and supply and use tables. Develop and use interactive dashboards for ocean accounts reporting like Norway is doing. Encourage international collaboration and standardization, which will become very important, cooperation. Invest in data architecture and engineering, and build know-how in national statistical offices. So obviously, the ecosystem services and economics of ocean products has to be tracked, and kind of an end-to-end life cycle analysis has to be done so that the solutions are not done sectorally and not done just for single issue, but is done holistically to benefit humans, nature, and economy, which is what the purpose of this report is. So we'll look at some other details in the coming podcasts. Okay.